We're going to look at bond energies, and we're going to look at how we can use them to work out the energy change for a chemical reaction. Now, what we've got here is if you break a bond, you need to put energy in. It's endothermic. Breaking is endothermic. Whereas if you make a covalent bond, if you join two atoms together in the bond, you get energy released, you get energy out. Okay, so for example, I'm going to give some bonds here. So for example, a bond between two hydrogen atoms. Like the bond. So that would be an H2 molecule. That has got an energy associated with, and it's measured in kilojoules per mole, of 436. So that means if you want to break a bond between two hydrogens, you have to put in 436 kilojoules per mole. Now, what does per mole mean? Well, it means 6.2 times 10 to the 23 bonds, the Avogadro number. Yeah, the number of atoms in a mole. We use the same thing here. One bond is obviously a tiny amount of energy, so we're dealing with large amounts of large numbers of them. We measure them per mole. Right, now we look at the bond between two chlorines. That is weaker. That's only 243 kilojoules per mole. And that's mostly because chlorine is a bigger atom, the bond's longer and it's weaker. And if we look at the bond between a hydrogen and a chlorine, that's 432 kilojoules per mole. Just a few other values. If you look at double bonds, they're usually stronger than single bonds. So a carbon-carbon double bond is about 612. If you add an oxygen-oxygen double bond, like in an O2 molecule, that's a 498. Okay, so just to get a feel of how big these values are. Okay, so let's use these bond energy values we've got here to work out the energy change for a chemical reaction. So if we have hydrogen reacting with hydrogen gas, reacting with chlorine gas, it will form hydrogen chloride. We don't call it hydrochloric acid till it's dissolved in water. So it's called covalent hydrogen chloride gas. Okay, so before we can do the calculation, we have to think about what bonds are present in those molecules. So sorry, that should be Cl2. So in the hydrogen, we've got a single bond between two hydrogens. The chlorine, you've got a single bond between two chlorines. And then we're going to form 2 moles of hydrogen chloride. So that's a bond, but there's 2 of them because we form 2. Okay, so we'll draw a box around them. Now what we're going to do is we're going to break up. We're going to break all of these bonds and break up the molecules into the individual atoms. So we're going to have 4 hydrogen atoms. Sorry, 2 hydrogen atoms and 2 chlorine atoms. And then here we're going to build up those 2 new molecules, forming the new bonds. Okay, so so this green arrow here, this is going to be breaking. Now breaking bonds is endothermic. And you may think it the wrong way around, but we actually always give that positive sign. So you just get used to giving it a positive sign. So it's going to be plus 436 for breaking the hydrogen, and it's going to be plus 243 for breaking the chlorine. That comes to plus 679 kilojoules altogether. Right, now let's see how much energy, so that's energy we've got to put in. Let's see how much energy we get out when we form the new bonds. Well, we're forming 2 of these bonds. So that's 2 times 432, which is equal to 864. And we're going to give that a minus sign because it is making, so that is exothermic, always a negative sign for exo. So the overall change then, we'll write down here. Well, we've got to go, first of all, we've got to put in 679 here. So that's plus 679. And then we get back 864 here. So minus 864. You do that on a calculator, you get a value of minus 185 kilojoules. Now that minus sign tells us that this reaction is exothermic because we've got a negative sign there. You get more energy out, 185 kilojoules, than you had to put in. So that's how we say minus 185 is the answer there. Kilojoules per mole of hydrogen reacting per mole of chlorine. Okay. Now, in an exam, your best if you get the right answer, generally speaking, you get the marks, 3 marks. But it's it's very easy to make mistakes in these. So it's a good idea to put the energy. Always write down that number. That's the energy you put in, and write down that number. That's the energy you put out. You get 1 mark for each of those, and the 3rd mark you usually get is for just working the difference out there. Now, if you worked out this one wrong, for example, you would lose the mark there, but as long as you showed you working out, you're still going to get the final mark, okay? So it's always worthwhile showing you working out, and you're much less likely to get confused as well. Right, let's look at another example now. We've got here, right, I've got 2 examples. We'll hide that one down there. Right, this one, we're going to look at the decomposition of hydrogen peroxide. Okay, so we've got that there. Now, hydrogen peroxide is away. Hydrogen peroxide, H2O2, and if you had a suitable catalyst, it will fall apart and it will form water and release oxygen. Right, so let's look at the bonding. So hydrogen peroxide, you can see you've got a single bond between holding the oxygens together. That's how oxygen manages to form 4 bonds in that molecule. And then it goes to form water. We're familiar with that. And the oxygen, the O2 molecule, which has got a double bond between the oxygens. And we've got our bond energy values, which are given to us here, always given to you. All right. So let's do the same again. We're going to break all of those up into the atoms that it's made from. So it's made from 4 hydrogen atoms and 4 oxygen atoms. And then we're going to build them back up again into the new molecules, making the bonds, and that will release energy. So let's do the breaking bit, which is of course endothermic. And so that's going to give us positive values. We're breaking 4 times of these oxygen hydrogen bonds, 4 times 464. And we're breaking 2 of these very weak, we can see there, oxygen single bonds, 144. Add all that up together, and you get plus 2,144 kilojoules. So we've broken it up into the individual atoms here. Let's build them up into the new molecules now. Well, we're going to form 4 times 464 again for the OH, 4 OHs, 1, 2, 3, 4 bonds here. Plus this one here, which is 498 for that one, for the oxygen double bond. Add all that up together, you get 2,354. And it's a minus sign because it is exothermic. Right, and so let's do our overall change. Well, that's going to be equal to the energy we put in, which is 2,144, give it a positive value. And add on the energy we get out, negative value, 2,354. Do that in your calculator, you get an answer of minus 220 kilojoules per mole. And the minus sign tells us that it is exothermic. Right, so that's how you do those. And again, always put down your intermediate answers. So put down that one, we'll get 1 mark for that. That one you get 1 mark, and then you get 1 mark for working out the difference here. And this is an exothermic reaction. Let's just have a quick look why it's exothermic. We can probably see that you're breaking this oxygen single bond. That's very, very weak. It's only 144. You break them, and you in the place of 2 single oxygen bonds, you make 1 oxygen double bond, which is worth more than those together. It's worth 498 kilojoules. So that's what's driving that. Okay, now there's one more for you to do. I'm not going to go through it because I think you've got the idea now, but I'll give you the answer. You can do it. Right, we've got here, we have got methane. Okay, we've got methane reacting, burning in oxygen. We know this is going to be very exothermic because it's obviously burning fuel and oxygen, and we're going to get carbon dioxide and water. Okay, and you've got to work that out, and the answer is actually you should minus 828 kilojoules per mole. So hopefully you'll get that. And if you just look what's driving this one is, so look at that carbon dioxide bond there, look at the value of that. It's really big, strong bond. You get lots of energy out when you form CO2, 805, and that's really what's making this so exothermic. Have a go of that one.